Okay. Bonjour toutes et tous. I'm so happy to be back to QT and see you faces again. And thank you, Michael, for a nice introduction. As Michael said, I'm going to talk about our ongoing work, Modeling 4.0, conceptual modeling in digital first era. So I assume that we're going to have diverse audience. I will quickly explain what I mean by conceptual modeling. So when we develop information systems, we use graphical representation to understand users' requirements, to be able to communicate with different people who are involved in systems development, to also reason about the domain that the system gonna represent. And this graphical representation often called conceptual models. And we have so different type of varieties of conceptual models. We can represent how different components within a system send a message to each other. What are the tasks or processes behind the system? How the data in the system gonna be? How we gonna collect or store the data in the system? So we have different methods how we're gonna represent this different aspect of this using graphical representations, of course. While it is very traditional approach of conceptual modeling, it plays very significant role in current system analysis and design tasks. So, for example, in large-scale software engineering, people are using multiple and different types of conceptual models to different aspects because it enables them to make it easier for people to understand complex systems. They use in open source software development. Actually, one of the researchers find more than 9,700 UML diagrams using GitHub to enable communication between different people who are involved in open software development, in agile projects, in big data initiatives. And more recently, people started to see how it can be used for AI to make it more easier to understand AI, or how we can implement Internet of Things, smart sensors, what type of data they can collect, or how we can make it reliable data. And also, people start to use it to conceptualize where we can automate business processes, so for robotic process automation. So it plays very significant role in system development life cycle, but it has been evolved very much from beginning very ancient history to the where now we stand. So this is the type of model has been used in Babylonian language. You can see that they use symbols to communicate with each other, right? And they start to draw something to be able to understand each other. And as the science has been developed, people start to realize that actually they can use it for different purposes. So people started to see that how they can use conceptual models to solve production problems. And one of the this is the very early version of Gantt chart, which we are using at this stage. And people start to use like presentation like this. These are the steps like you attach, and then you say what is the operation, what is the task, what are the tasks that it should follow, what are the preceding tasks, how much time it takes to finish the task. And this basically has been used to manage workflow in earliest stage. So we call this as modeling 1.0. But later on, information system analysts and designers or information system professionals also recognize that they can use this type of models to understand users' requirements, to communicate with people. And they also realize that it is better if they use more formal approach to develop this kind of models. And then theories, meta theories or ontologies are evolved. And based on those, then we came up with modeling languages, modeling grammars, like Petri nets or entity relationship diagrams. Grammars, they provide a set of constructs like shapes and arrows, and the rules how you can use those shapes and arrows to meaningfully represent something so people can understand. And then later in mid-1990s, we had object-oriented designing object-oriented programming, which we created another wave of conceptual modeling, and then new advanced methods, new advanced languages and grammars are arrived, like BPMN or UML class diagram or DFD, data flow diagrams, or event-driven process chain (EPS). So then basically people start to use more formal approach using advanced or the not currently advanced, but using more formal grammars to represent different aspects of the system. So we call this stage modeling 2.0. But as you see, there were lots of different type of grammars evolved and proposed. In the next era, the IS professional realized that maybe we need to integrate them because we have so many different aspects. So how we can combine them to make or to provide a holistic view of a system using different type of models. As you saw in the previous slide, some models show how the messages are flow, some models show the data, some models show the processes. So they develop new methods to combine them to provide more holistic view, which we could, then the new methods came up such as model-driven architecture or Archimate or architecture of integrated information systems. In this era, also people started to develop tools. So the tools enable people to develop models and also correct them based on the grammars if they do some mistakes. Some of the tools that maybe some of you may use already, like Visio or other tools like ARS also is a tool. And in this era, we also had domain-specific languages, which they are developed to be able or to enable users to represent domain-specific knowledge, providing more different components. But when we came to digital first era or our digitalization age, we are provided with different capabilities or new capabilities and affordances, which enables us basically, some of these affordances are which enable us to access and analyze very large scale of data. It enables us to provide cost-effective personalized artifacts. It also enables us to visualize in different ways or use different tools such as digital twin or augmentation to visualize something. But the current conceptual models are mainly static and they represent the current state of the system. And they basically, they are constrained in scale. They are presented, they are not flexible. Let's put it this way. And they require higher maintenance in terms of developing, first of all, designing, updating them, or personalizing them, or maintaining them in our role. So based on this, based on the new affordances and the current state of conceptual modeling, I don't know how I can make it disappear so you can read it. Okay, so based on this, sorry, I cannot read in the top line. But based on this affordances and the capabilities that we had in the digital first era, we say that conceptual modeling needs to respond to emerging needs, needs to respond to the capabilities of the digital landscape. And then we looked at Industry 4.0. We say that Industry 4.0 changes how we work, how we develop stuff, how we develop products, how we deliver products, how we provide services, how we communicate. So based on this, conceptual modeling also needs to be updated. It is not, it cannot represent the current environment or current domain that digitalization is going to create. It's not able, it's not capable, or it may not have enough constructs to represent the new environment, such as smart systems or intelligent systems. And it also doesn't have the new affordances to use the augmented techniques to model. Yes.
Just for my understanding, on the one hand, you talk about conceptual modeling, which is indeed mainly an IS thing.
Yeah.
And you also talk about modeling more in general.
Yeah.
But then you also have to take engineering, design, a lot of other domains. So Are you mainly focused on conceptual modeling or on modeling?
Now we are at this paper, we are more focused on modeling, conceptual modeling, not modeling in general, or not business models, all this kind of stuff, or engineering models. So based on the Industry 4.0 principles, we say that the way we model, why we model, what we model, and how we use and design models may need to change. And then our objective in this work was to address a research question: what are the new principles and mechanisms of conceptual models in a digital world? And we call it Modeling 4.0. To drive design principles and mechanisms of Modeling 4.0, we relied on design principles or main principles of Industry 4.0. Industry 4.0 has 6 main principles, and based on those 6 main principles, we developed 12 mechanisms, which in next slides, I will explain them in more detail. So the first design principle is interoperability. It talks about the seamless flow and exchange of information between different components of the system. And based on this design principle, we developed 2 mechanisms: consistent models and expandable models. Consistent models refer to the faithful and consistent representation of domain across multiple models. Okay. So if anything happens in one aspect of the domain, all the models should be consistent to represent that changes. For example, if you change your strategy and be partner with one of your customers, then that customer should be presented as partner in your process models and your data models, because you change, and that change should happen immediately to be consistent across different models. Then we had expandable models. So interoperability talks about capability to integrate, share information, so every component can collect information and gain insight from the information. Expandable models say that multiple models that we develop should be correlated to each other, and users should be able to get information across multiple models. For example, a user can look at the data model and get a taxonomy of customers, and then dig into the process model to see which processes are related to that customers only. Okay. Design principle 2 is virtualization. Virtualization is developing or presenting a physical world in a digital environment. And based on that, we had 2 mechanisms: digital models and augmented models. Digital models provide a semi-realistic view of the system, and it enables to check and evaluate the behavior of the system. So digital models, for example, would enable users to understand how the system behaves if there is a fluctuation in the demand. So, or for example, if a storm happened, how the processes of call centers in insurance industry may change. Then we had augmented model. Augmented models, they facilitate interplay of human and machine. So we use semi-automated tools to design and implement and understand the system. So the different tools can be used to basically enable machines to read the models and also implement the models. And for example, AI can be implemented in designing a system to detect or to cover the design preferences. For example, if a user wants to, for example, a model can change the size of a modeling element or change or highlight a modeling element based on the context-specific situation in a model. Design principle 3 is decentralization. It talks about moving away from centralized control system to self-organizing, decentralized entities. These entities can autonomously process the information and make decisions. Based on this, we developed two mechanisms, autonomous model and categorized models. Autonomous models refers to the modeling from bottom-up approach. So in the traditional way, we always use top-down approach for modeling. So we know the domain in general, then we break it down and we model a specific part of the domain to understand that specific part only. So we have a general view, but we model one part only, and we develop multiple models to represent the entire domain based on our understanding or our mental model of the domain that exists. But autonomous model use the bottom-up approach. They develop a context-specific and very specific operations that can be generalized later to represent the entire domain, but these are basically developed without having the prior information. For example, consider process mining, right? They use timestamps, they use the data, they use resources, they use the sequences to mine or to develop a model without actually having the prior information how that model would look like. And then later on, they may generalize it to a specific purpose. Categorized models enables users to categorize different models based on a specific context or based on a specific problem. For example, imagine that you can categorize your process models based on a resource, or what resources, or based on the resource that they share. So, yes. Do we have any question? Okay. So feel free to ask question if you have. Okay. So don't wait. You can stop me anytime you like. So yeah, categorized models enable us to answer what-if questions. For example, if you categorize your process models based on the resource they share, then you can ask what will happen if there is a lack of these resources. What processes will change? How they will change? Okay. Then we move to design principle 4, real-time capability, which is the capability to collect and analyze data on real-time basis. And based on this principle, we develop zero latency models and predictive models. Zero latency models address the problem of time to model. If you remember in the beginning of my presentation, I mentioned that developing models is time consuming and is costly. Zero latency model enables users to develop models as soon as possible and reflect the changes within the system, within the models as soon as it happens in the reality. And so we can use more automated tools to develop this kind of models. Predictive models, they develop based on signals that can be used to represent future aspects of the system without actually it is happening in the reality. For example, consider a process model that enables you to understand what activity you can add, for example, to improve trust in organization, where that activity can be added, or where in the process you can add a new activity to check eligibility if passengers required to have forced vaccination, for example. So you have that, you can see that in the model prior, actually, before it may happen in future. Then we have design principle 5, talks about service orientation. Service orientation is about developing and delivering products and services based on customers' preferences. And based on this principle, we develop two mechanisms: personalized model, affordable models. Personalized models enable users to personalize the models based on their needs. For example, consider risk assessment manager who wants to see only the risky tasks or the likelihood of the task. So they can personalize the model to only highlight those tasks to them. Or if you are a budget manager, you want to see what is the most costly resource for you. So you can only highlight those part of the models to see how is the most costly part, or which processes are most costly. Then the affordable models are the models that enables us to decrease the cost of the modeling. Using current tools or developing models based on the current grammars and tools is time consuming. We have to educate people how to use the model, how to use the tools and grammars. But using a new automated tools, AIs or machine learning or natural language processing, we may be able to develop augmented model, affordable models. Actually, there are few research currently going on. For example, in process modeling environment, they use process query to mine or to get the models from repository to identify which part of that models can be used for their own purposes, and they combine model from the repository to create a new model without actually developing the model from scratch. So they use the old models that are in the repository. They see different aspects and they combine different aspects to develop a new model. So they decrease the cost of the model. And finally, we have design principle 6, which is modularity. It is about the system's capability to deal with the changes or unexpected situation that may happen. And based on this, we developed two mechanisms: robust model and agile models. Robust models, they stay valid both in the ordinary scenarios and in the scenarios that are not that we cannot predict them in advance. So their level of granularity is higher than the real time or the physical world. So they always present and they always provide an acceptable presentation for different scenarios. Agile models are interactive, adaptive models that enable users or enable developers to change the model as soon as to respond to the emerging requirements or respond to the changes that may happen in the domain. Agile models also can present different scenarios. So you can, for example, you can use a specific type of processes if we need to use online interaction in place and keep the physical interaction hibernated during the pandemic, for example. Agile models can provide you different processes based on the different scenarios that you may encounter. Based on this mechanisms, we try to explain how the next generation of conceptual models can look like and how they can adapt to address the new emerging requirements of digital world. We believe that the next generation of conceptual models, are not limited to the artifacts that are presenting the predefined characteristic of physical world. They are adaptable and they can enable users to interact with their context, with their developers, and they can be agile. Next generation of, and also these principles and mechanisms can help developers to develop a new tools which can provide more capability to develop personalized models, or to basically to enable users to collect different type of data, so they can develop models based on the real-time data analysis basis. So we say that conceptual models can afford a variety of new capabilities, and it will enhance the current limitation of the generalized current limitation of static and generic traditional conceptual modeling methods. Thank you so much.
Thank you so much, Mark. Now, by the way, stop sharing so we can see who's online joining us.
Yes.
So Sure.
Thank you. I think we have a question.
For your comments and feel free to start online. Yes.
Yeah, so great presentation, Mohammad. Thank you. I have a question. Are these design principles developed through review of literature? No, we developed them based on the design principles of Industry 4.0, and we followed basically more, I would say, more type of like design science approach to develop these design principles. I hope I answered your question. So we didn't go through the literature to see how people are talking about next generation of conceptual modeling.
Questions from the audience?
Yeah.
Good. Good, and then
Yeah.
Rose, red, and green.
Yeah, thank you very much. Yeah, I think also, especially to this question, so are these design principles from Industry 4.0, are they published somewhere, or how did you came up with them? So not
Industry 4.0 principles,
Yeah,
yeah, they have been published and they are very well known. Yeah. Those 6 principles that we draw based on them, they are well known. Yes. They have been published, I think, in different journals already. Yeah.
And how do you think the concept of digital twins would relate to that?
So digital twins. So we had digital models. If you one of our design mechanisms, it's quite similar to digital twins, but in the conceptual modeling environment, we try to focus on evaluating and checking the system behavior. It is quite similar to how the digital twin behaves, or how the digital twin is going to be used. So there is a overlap on those both definition, I would say. I cannot say they are completely different.
Yeah, because I think that's quite interesting, because you have the physical machine, then you have a digital twin that could be already a kind of model,
Yeah.
or is a kind of model, and then you have maybe a very abstract models.
Yeah.
On the very abstract concept.
So in the digital twin, we have a physical machine, but in our digital models, there is a system. So system is also a digital artifact.
Very organic segue. I was working on a research project for digital twin.
Yeah.
And my question was a bit philosophical.
Yeah.
So most models fail, right?
Yeah.
So how do we build resilience in our models, or how do we build robustness in the model? You talk about robust modeling, but then how do we build? Let's say if you're building something conceptual and physical in these layers, which is digital twin. Digital twin kind of a methodology and a model. So how do we build resilience in our models, which is, it will fail, right? We expect them to fail, but how do we build the robustness?
So that is actually a very interesting question, and we also just published a paper on organizational robustness, and we went through different scenarios how organization can be robust. But there are, of course, limitations. If you design a robust, you also are more fragile. Yeah. So there is always pros and cons, or there is always you have to trade off. And in this case, to build a more robust model, I think this is just, we didn't implement the idea yet, but in future steps, I think we may mainly focus on how it's gonna be data driven. And if we are able to actually analyze data at the same time, and are we able to transform that information that we generated to be presented in the models? Yes.
Absolutely. Yeah, because I was following up on your. I find it a bit doubtful that Industry 4.0 is the right starting point to think about next generation modeling.
Okay.
Comment.
Yeah.
And the question is, and it's a bit of a boring question.
Yeah, no question is boring.
Like 6 principles and 12 mechanisms, 14, 15, or 3 or 4, and like one of your mechanisms is modularity, like what I would miss there is composable models, mashups, or I could say, where are the trusted models? So yeah, it's very tricky with these lists and overviews and where to start, where to stop.
Yeah, of course. I think every research that we do has some limitation, right? We cannot say that what we develop is a complete complete and more
Yeah, but like
effective
in
thing.
interviews, we use theoretical saturation as an excuse.
Yeah.
So yeah, what would be a good reason to have a certain number, or to say we are complete, or at least we have sufficient? Or
So when we went through the 6 main principles, we actually looked at what mechanisms we can develop to cover those principles. So we believe that the two mechanisms that we develop for each principle actually covers them. So if we feel that no, actually there isn't, so somebody could argue, yeah, you are missing something. But in our discussion, we thought that the mechanisms that we cover are more general, or we try to make them general to be able to cover the principle. But of course, there are always arguments that we may not be able to cover it.
Yes. It's a very interesting research, Mohammed, and also very important. So most of, I would say, all of the existing, or every modeling technique that I know is applicable for classical information systems, websites, workplace systems, e-commerce website, online shopping. We use UML, Unified Modeling Language, FMC, DFG. And this question, if a student comes to me and asks the question, can I use those models for systems like an AI or for IoT or digital twins? I just say I don't know how.
Yep.
So your research is certainly important. I believe I'm very brave and a little bit crazy. What needs to change to enable us to actually implement those design principles? Do we need to have more shapes, more arrows, or what needs to change?
Yeah, in terms of it has I think I can make a very deep argument. In terms of ontology, I believe that there is no fundamental change how ontology explains what is the digital world and real world. We can use the current ontologies to define it. We just need to define the properties in a better way, in a more smart way. And when it comes to the properties, we just need to extend the current grammars to enable to use those properties.
Right.
We don't need to have a completely fundamentally new grammars. I don't think so. This is my belief. But yeah, we don't need to have. We may need to develop new constructs based on existing constructs to fit in existing grammars.
Mm-hmm.
But we don't need to have yet another workflow language. Yeah.
So since my question is related to this comment, actually,
Yeah.
so I prefer to ask you. I think that we need new ontologies in the sense that you talk about some sort of social materiality.
Yeah.
But the previous models were about the just material nature of the technologies and IT. But now they are interactive, they are more social material.
Yeah.
Then I think that the properties of the reality has been changed right now. And based on this, I think that we need a new ontology for that. So that's not only about the material nature of the IT. Now we are talking about the social material nature of digital.
Yeah.
And based on this, we should develop new ontologies, I think.
That's a very interesting question. I think there is already debate in social materialism and using the ontology. There is a very famous paper in JIS actually compared the social materialism ontologies with Van den Weber paper. They are always ongoing discussion, and I believe that we need to somehow merge those two types of ontologies. But I'm not sure if we actually need an ontology. So we may adopt them from each other, but not completely new thing.
Yeah.
There's my question.
I wanted to refer to Irvin's question.
Yeah.
Because so I really like the structure with the 6 principles and 12 mechanisms, right?
Yeah.
But yeah, maybe because that's a lot for one paper already. Maybe there are really some overlaps, and you can combine these. Because if you think of agile, the consistent one.
Yeah.
And these are just like that the model is consistent with the machine, basically,
Yeah.
right? Yeah. So maybe it's not 12, but maybe it's less, so that gets a little bit easier. And maybe there's also some principles that don't apply really to modeling. That are just like Industry 4.0 specific, but it doesn't really change modeling.
Yeah, no, I completely agree. Before the presentation, we actually were talking that there is overlap between our definition. Like you mentioned agile and the digital model, consistent model. I was mentioning.
Yeah, real-time consistent.
Yeah. So these are like, there are also few others that they are overlapping in how we define them. And if you look at the Industry 4.0 principles, they are also overlapping their principles as well. So they are not avoidable, I guess. If you want to build a principle, that principles are going to be used other principles somehow. Now at this stage, we explain our mechanisms individually, but as you said, we need to combine them to see how they are going to come and emerge together to represent. If we want to develop, can we actually develop a model based on those 12 mechanisms at the same time? So we need them. We haven't discussed them yet at this paper.
That's really good to hear, because I had the exact same question: is how do you you have decentralized versus autonomous, and how do you align things with fluid communication? And I was exactly thinking, do you need more shapes? And I was thinking, well, it's almost like a color spectrum, and you just have to figure out what the project, where in the color spectrum you put it on. So there's not defined boundaries, because everything overlaps and integrates together.
Yeah.
And I was just thinking, how do you have transverse versus agile? Like what differences do you find, because there's such similar concepts together?
There are some individual concepts in each mechanisms, but as I said, they are overlapping. For example, in agile or real time, in agile means that you have different scenarios for different purposes, right? But in the digital one, in consistent one, whatever happens immediately is represented. So it is not like you represent different scenarios. It is represent what is happening already. There are different components for each mechanism, but they are not completely different or separate.
Does that then create like a 12 factorial of possibilities of potential models that you'd be slotting into?
Yeah. Well, I don't know, maybe.
Yeah, I think my question related to the previous question I partly answered, because I was interested in which direction are you heading with this design principles, because it sounded like, for me, it also sounded like you want to establish like a new ontology or a new language. But yeah, so what is the ultimate goal? But it sounds like it's kind of a meta level to existing approaches. So what is the goal?
Yeah, so the goal, thank you for the question. Actually, in the paper, we also mentioned that these are main mechanisms, right? And based on these mechanisms, our objective is to develop requirements to be able to implement each mechanism when we are developing models. So the next step would be, what are the requirements to be able to actually actualize or implement these mechanisms that we already proposed? This is the main idea. Of course, there will be research stream or research program on that. Yes. Yeah, I think.
So maybe, Samanthi, if you maybe unmute yourself, would you mind sharing your question?
Hi, Mohammed.
Hi.
So I just wanted to know, like, are there any software tools or simulation tool which use Industry 4 design principles at the moment, or are you going to develop any tools?
No, there is no tools that I could say that they all use the design principles of Industry 4.0 at this stage. And for us at this stage, maybe later on, we may develop a tool, but it will be a very long process how we kind of come up with the first step is to develop the requirements, and hopefully that requirements will help us to develop the tools. Yeah, in one of the research opportunities I mentioned is that these mechanisms maybe motivate developers to develop more advanced tools for later on. But at this stage, I'm not sure is there or if there is a tool.
Thank you, Mohammed. Thank you for interesting presentation.
Interesting enough, Samantha, I'm just going, but she used to work on a project called Industry 4.0 Readiness Assessment. Yeah, so something similar here. And Leandro, if you don't mind, maybe also reading out your question, please.
Hi, Michael. Let me see. Am I here? Okay.
Yeah.
So, yeah, I had two questions actually. Hi, Mo. How are you doing? So actually the first one is, can we say all the 12 mechanisms that you presented, are all of them new? I mean, in the sense that they didn't exist before, or some of them, I don't know, an evolution, update on things that already existed before? That's the first question. I mean, trying to compare the digital versus the previous, the non-digital. And the second question is if you would see anything on user experience, for instance, models being more easily consumable by users, if that could be a principle, or maybe if that you think it could lead up to a requirement in the future. Just trying to understand how how this discussion could fit in your model.
Yeah, thank you so much for the question. So not all those mechanisms are not entirely new. So we develop based on we develop, of course, we start with Industry 4.0 principles, and we develop based on the existing knowledge that, for example, Agile models, we know Agile programming exists, but it doesn't exist in modeling environment. So we adapt it to the modeling environment. For example, there is a consistency already in a traditional type of modeling, but it is not automated, or it's not a smart consistency. So we develop and we say that in digital world, the consistency should be it should be a new format, which we explain in this paper. So they are not entirely new, no, but they are new for conceptual modeling, but not entirely new in other fields. And for the user experience, I think a few of our mechanisms are related to user experience, and later on we're going to develop requirements based on them. For example, personalized models are related to user experience, or affordable models are related to user experience. But of course, they are not detailed enough to develop requirements how you can make it actually use, or how you can actually develop a digital model that is usable for information at the digital stage. No, we haven't yet developed the requirements for developing user interface or user experience.
That's wonderful. Thank you.
Second last question, Owen.
Yeah.
I will talk later, but you talk about requirements, and I think you've been going down into the mechanisms. But what I felt is that maybe you need to go up. Like saying, okay, who are the main users, or what are the main use cases? And then, okay, if you want to, let's say, just design a system, then these two the principles are most important than these mechanisms. If you want to have a simulation, then you use these two and these. So kind of navigate different users or different purposes through this list of principles and mechanisms.
Okay, so for different use cases, you mean that we may regroup different requirements for different
prioritize.
Prioritize.
Like if I want to have a digital twin kind of real-life data-driven model,
yeah,
I may emphasize principles like, okay, because like your boss has said, implement 12 mechanisms is quite a challenge. So you may say, if I want to have a data-driven digital twin kind of, that's my purpose, then I focus on modularity and this, and in particular these two mechanisms.
Yeah, that's a good point. I guess I don't know whether we need to go up to regroup them. We need to see what are the similarities already in the mechanism, so how we can group the existing similarities. We were thinking in that way, or maybe we may need to go up in the higher level.
Yes, similar comments that I have is that some of those mechanisms and the requirements for implementing them would be different for AI, which is not known as a socio-technical technology compared to IIoT, Industrial Internet of Things, which is much more cyber physical.
Yes. Yeah, I believe some of the not all mechanisms gonna be applicable for every model. That is for sure. So for some context or for some purposes, you need to use different mechanisms or combination of different mechanisms.
A very good conversation. And I really appreciate that you all showed up and contributed, knowing that modeling 4.0 is not the core topic for many of you. But I think that characterizes a nice constructive research culture. We're curious beyond our comfort zone and make contributions, sometimes beyond our immediate area of interest. Assuming there's no more question from the online audience and no more question from the inside audience, from all of us, merci beaucoup. Thank you so much for joining us. This has been a short, spontaneous visit, jet lagged. So we're incredibly grateful. Peter, you worked, read, published more than anybody else in the conceptual modeling. What are your final words on why we're sitting there? I felt like the Muppets here, but they flew out men sitting on the most comfortable couch.
Exactly. Yeah.
Peter, what do you think about modeling 4.0?
Well, I was sort of interested in the possible conflict between some of the design mechanisms. Robustness not change as the real world changes seems contrary, a contrary design principle. The other concept, the other question that occurred to me is how much work has more work or more advancement being done in one or two of the design mechanisms than in other of the design mechanisms?
In modeling field, or yes, there has been some of the, for example, augmented modeling. So people start to use natural language processing to extract user requirements from user stories. So machine actually develop a use case diagram from.
Why do you think that is? Why is some of the design mechanisms advanced further than others?
I think the applicability of the technologies that we have currently, it's like they are doable, more doable than the others. It's the main reason. It's like for natural language processing exists, and it is actually easier than we just talked before, like understanding or detecting inconsistencies is much difficult than actually detecting what users are saying. So it is easier to do natural language processing than to developing a smart tool to detect inconsistencies between two models. So they are more doable.
Thank you, Peter. Would you mind quickly bringing up that sort of clock?
Yeah.
Again? So many comments came up and say, shouldn't there be 15 or 8 principles? And why don't you have sometimes 4 and sometimes 1? Why is it always 6 times 2? To be honest, sometimes it's nice to be beautiful. Yeah? So this is the very first draft. And what we share right now, it's 2 times 4. It's not 2 times, sometimes 3, sometimes 5. So sometimes our very first models are intentionally symmetrical, consistent. I don't say we give the world the next 7S model like McKinsey, and they can do this because it's utility and not truth. But as a starting solution, that's what we have. But I think surely we could have added another 4 principles easily. And you made great contributions here already. So I think it's also true to say that this is not a pure inductive, and we capture whatever we could find. In the first attempt also to take a certain audience, sometimes a symmetrical or beautiful artifact gets a bit of attention. We will always put truth over beauty, but to our best of our abilities. It's our starting solution, but it doesn't strive for completeness. That's what we publish here. But we ask ourselves, with Jan Weckler, we work on this idea, why do theories have to be ugly? Can you find ways to make theories a bit more easier to consume and just not improving the what modeling people call pragmatic layer? It's like language. Yeah? We teach you syntax and semantics, and then beauty comes when pragmatics kicks in, when metric kicks in. This now under review for a journal, see how we go, but at least you're all aware of what's out there. And I think each of them could take more than one PhD in isolation.
Should they be used for design or evaluation? And what I mean is, rather than actually driving advancement, that you evaluate models according to these principles and say, well, it doesn't have this, therefore it could experience these problems. And then people who are doing the design in that area will say, well, that doesn't matter for this context.
Yeah. So they can.
That's what I think a lot of the questions have alluded to.
I think they can apply in both ways. They could have, like, one of my, like, in consistency principle, I am already doing consistency checking, right? Whether there is a consistency between different models, or personalization. We are actually doing a project on personalization. Like we try to see how, based on different characteristics, we can use colors to get people's attention in models based. Of course, it is type of personalization. So I think in some level it can be applied for evaluation as well with the current models.
Very last question.
Well, I was just gonna say, could you not just fill in, you're saying, could you not just remove I mean, I like the idea of more shapes, more simple colors. Could you not just literally remove all the different lines and take what Erwin said, as you have a project, you will put it close to one of those 12 compartments, knowing that the adjacent to it's actually gonna be the weakness of it.
Yeah.
So the closer to the center, the more resilient the project is, but the further to the outside it is, the more likely it only compares to one or two aspects of it.
That's a good idea.
It'll be on the paper.
Anyway, that's a really good idea. Thank you so much, Ryan. Before I head over to Vic, because I would love that you give us a kind of 2-minute summary of what happens in ICB. We would love to thank you again, Mo, for making this approach in your schedule. Mo's here for another 2 days, at least in Brisbane.
Yeah.
We hope to see you very soon again here, but one of you finds its way to Quebec, or means knock at the door of the University Laval. Thank you so much.
Thank you so much. Thank you very much. Merci beaucoup.
Vic, what happened in ICB? I think what happened here, come here. I'm not sure if you know what's happening in the ICB, but I think it's quite fascinating. You might have seen some